Hello everyone and welcome to NetWiz YouTube channel. Today we are going to talk a little about one of the very first concepts in dynamic routing that a network engineer learns about, split horizon. Split horizon is a loop prevention mechanism in RIP and EIGRP, and chances are if you are in networking you know what it states. Here is a screenshot from a quick Google search on what split horizon is. Wikipedia states that in computer networking, split horizon route advertisement is a method of preventing routing loops in distance vector routing protocols by prohibiting a router from advertising a route back onto the interface from which it was learned. And this is a very good explanation about what it is. However, although both RIP and EIGRP implement distance vector algorithm, when it comes to split horizon, there is a tiny difference between them. Now let's look what that difference is. In our topology, we have three routers, R1, R2 and R3, that all share an Ethernet segment with a subnet address 192.168.0.0/24. R3 also has access to network 192.168.10/24. To begin with, we are going to run EIGRP between R1 and R2 to exchange their routes. Now EIGRP have already been pre-configured, so let's start by verifying the routing table on R2. And we can see that R2 learns R1's loopback address over EIGRP protocol. Let's verify R1. And the same happens here. We're also learning router 2's loopback address over EIGRP. Now if you noted, R1 also has a static route for 192.168.10, which is a network behind router 3. What we want to do now is to advertise that route over to R2 using EIGRP protocol. So to do that, I'm going to configure route redistribution in EIGRP. Okay, that is done. Let's see if we see that route now on R2. And sure enough, we have now a external EIGRP route for 192.168.10 with a next hop IP address of 192.168.0.1, which is R1's Ethernet 00 interface. So far so good. Let's see now what happens if we try to do the same using RIP protocol. So to do that, I'm going to shut down EIGRP on both interfaces. I've got RIP also pre-configured, so now that EIGRP is shut down, the routers will use RIP routes for their routing tables. Let's verify that on R1. And we can see that we are learning R2's loopback address over RIP protocol now. Just quickly make sure same happens on R2. And sure enough, we have got a route for R1's loopback address. Now let's go back to R1 and try to redistribute our static route into RIP this time. And going back to R2, let's see if we now get it in our routing table. It's not there yet. Maybe we need to give it a few more seconds just to converge and to receive another RIP advertisement, because we've got RIP timers at the default. But still not. Look, we have got a fresh route update from R1 with its loopback address, and it happened just 10 seconds ago. But we still do not see our static route being advertised to R2. Now the question is, what stops this route from being advertised from R1? And the answer is, it is split horizon. But wait, we didn't learn route for 192.168.0 1.0/24 via Ethernet 00 interface on R1. This is where this subtle difference comes into play. For RIP, the rule should state, do not advertise a route out of an interface on which the next hop for that route is found. In our case, next hop for 192.168.10 is found via Ethernet 00 interface on R1, and that's why RIP doesn't advertise it out that interface. Well, let's prove it by disabling the split horizon on Ethernet 00. And that should stop split horizon rule from blocking that advertisement. Let's go back to R2 and verify its routing table. And sure enough, now we do receive this route for 192.168.1.0. Note the next hop address as well. It is not pointing to R1, but instead it is pointing to R3. So this is what the difference is between split horizon implementation in EIGRP and RIP. It is very, very specific, and this is probably the only scenario where it would matter, but it's still worth remembering that little difference. I hope this video has been helpful for you. Thank you very much for watching, and until next time.